Hello everybody, welcome back to another edition of the Modicon M221. I'm your host Leandro Mada, and in this video we're going to talk about the different home modes that we have in the software. So let's go to the presentation. So before starting with the different movements that we have in the software, it is important to know this, which is the motion state diagram. That basically it gives us an idea of the different states that we have using the function blocks in order to navigate between the different states. So let's take a look on this. So let me just put the pen. There we go. So in the previous video we saw this function block, which is the read state, okay, and using the axis state, okay, it gives us an idea of the motion state diagram, which is all this stuff that we've seen before. So this is an explanation how you can execute the different function blocks inside the software. So the idea now using the home is to be in this area. Modes that we have in the software, so we can see the difference between them. So let's continue with this. Okay, so if we are going to use the home, it is important that we need to define in the configuration of the PTO that we're going to use the home, and we are going to assign a specific input in the software for the homing. Otherwise we don't have anything to link the real world with the homing that we want. Okay, so when we are in the configuration of the controller in the PTO, let me just show you this quickly. Here in the configuration we should be able to assign in the homing a reference. This reference can be linked to a normal digital input, so we can define that this input will be linked to a sensor, that this sensor will be the home in our case to assign the motion. And also we have the possibility to define if it's normally open or normally closed. So I'm going to close this and continue with the presentation. Okay, so now that we know that we must have a digital input for this, we need to know that we have different homes. Okay, so let me just change the view. We have these 4 homing positioning. Okay, so the first one I believe is going to be the easiest one. So we just execute this, and the position that the axis is at the moment is going to be the 0. Okay, simple. But what I want to focus is in these 3. So how we can use this homing is the same as we saw before. We just need to go to the configuration, select the function block for PTO, then into the motion, select one power, because we need to power the drive is power, because we just need to enable the use of the function blocks. Okay, and if we match the output with the input of the driver in order to make it work, it's going to be the power. Okay, so then you should have the home over here, and this is how it looks like. You can see here there are different things that we need to configure. Okay, the first one will be the axis, and the second one will be the mode. And depending on the mode, we have different things that we should configure. So if we want to, for example, access remotely and change the mode and the direction that we want to use, we just need to use the instance of the home that we have, and then assign a %NW variable to these parameters of the instance. Okay, for example, if we want to change the mode, just use the instance.mode, the direction, the instance.direction, and these are the values. If you use the -1, you just go reverse, 1 forward. And these are the different mode that we have. This one is the default one, okay? But I'm going to use focus in these three. So we continue with this part. This is the other important parameter that we can configure, which is the offset. So after we have made the offset, we have the possibility to specify an additional movement to move to the desired position. So imagine that you have the machine, and you just go to the home, and then we can specify, okay, now that you have the home, to just make the offset to the position that you want. Okay, so home, position, and then the movement, the absolute movement to the position that we have specified here in the offset. So continue with this, and then the rest of the elements can be easily identified. So just use the name of the instance and then the name that you appear over here in order to identify that, in order to make the change. Okay, and it's important to configure the high and low velocity, because depending on the mode, we have different approach to the home. So let's start with the long reference. So the idea of this long reference, this one is when you are with the reverse position, but I'm going to explain everything on the forward positions. It applies, it's the same. So this is your machine, okay, and in this position is going to be the home, okay, as you can see over here. So the machine will start going into the position, okay, at a high velocity. This is important to configure the high velocity. Once it reaches the reference that you have, okay, it will go in the different position to find the axis again, okay, the reference, the home, but at low velocity. Okay, that's the idea of this. Okay, and now this scenario is when you, for example, the machine is located next, or when the reference is activated. Okay, you can see over here the reference is activated. So now instead of moving at high velocity, it just go in low velocity, okay, in the reverse way, because it's already in this part, to reach the home position. Okay, so imagine that that's why it's good to have different homes and the possibility to change. For example, you have the machine in one part that is not close to the machine. Okay, so if you go to low velocity, probably it's going to take so much time to make the homing. So that's why you have the high velocity. So it goes, it's moving, it reached the home position, then just in order to accommodate and be the right part, it's just going to low velocity. So it goes to the home. Then let's continue with this. The next one, probably I can show you, let me see. So let's test this one first. I have this program. So let me see. Here is the application I have, and it's linked to the I04. So MC power is working. Okay, home position. Let me see if I can show you the axis. Okay, so home mode. So the home mode here, it should be assigned to the number 1, okay, which is the long reference, positive direction. So if I know, it should be going from this side, like this. So let's go over here. So I have already created some formulas here. We're going to cover that later, but here in the position, you just need to assign the number of pulses that you want. Okay, I already have the formula. So home position, move velocity. Here is the offset. Okay, let's try it with 0 and then with another one. So here, home velocity, I want it to be, for example, high velocity, 100 RPM, and this one 5 RPM, low reference and everything. Okay, so let me just try to adjust this so you can see it. So now I'm going to activate the home, and it's going to be in high velocity until I reach this the input. This output Q4 is directly linked to the I04. Okay, so I can manually attach it. So in theory, now if I execute the home, it will go to high velocity until I reach the home, which is the sensor, and it will go in reverse in low velocity until I disconnect the home. So I'm going to activate it. Is it wrong? Yes. So you can see there is in high speed, okay, high velocity. Now, if I remove the home, if I press the home, okay, it will go in reverse in low speed. So low speed until I remove this one. There we go. Okay, so this is how the long reference work on the machine. I don't have the physical sensor. I just simulate the input in order to make it work and show you, but I believe you get the idea. So let's try now explaining the other one. Okay, so let's go with the short reference, no reversal. So it can be similar to the previous one, but we have the name short. So probably instead that the machine is not close to the home, okay, you can use the short reference for no reversal. So if it's close, you just, instead of moving the high velocity, just go to low velocity to the target in the position that you want. So just change the screen. So machine, this is the start, this is the reference point, as it's going to be the home. So we just go in the home, okay, forward in low speed, and as soon as it's seen, it just stop. Okay, and here is another case, is as we don't have the reversal, okay, just going one direction. If you are imagine that this is your home and you need to go into this direction, okay, if you are in this direction, it will stop over here. But if your machine is in this direction, okay, it's just going to that direction again, and you're going to touch the limit switch that you have. That's why you have this error over here. That is indication. Okay, so let's try this now. So if we opened this again, okay, and going to remove this and show you this one. So the velocity, we have the low velocity as you saw, which is the low velocity. It's very slow compared to the other one. This one, no reverse, it should be 21. Okay, short reference, no reversal. So so now in theory this will go in this direction, okay, like this, until I press the home position. So there we go. You can see it's in low speed, okay, compared to the other one. You can see it is low. After position, velocity isn't going to the low velocity, as you can see. And now what we can do over here is to stop it. Okay, let me just try to simulate that it reached this part over here until now. Okay, so it reached the 0, and the actual position of the movement should be 0. let's see, read after position is 0. Okay, so now what we're gonna do, I didn't show you in the previous one, but let's add an offset. The offset is gonna be here, we see it, it's in this one. You cannot see it. Okay, the offset is going to be this part. I'm going to assign 130 degrees for the offset. So if I select this one and select 180 degrees, okay, there we go. So now let me see, it's already home. So the idea of this is the following. I'm going to execute the, but you cannot see, but it's the home over here. So what I'm going to do is to execute the home again. So we go low speed over here until I touch the home, okay, and then it will move 180 degrees because of the offset. So home, and executing the home. I'm going to try to stop it. An indication home. There we go. It's in home, and now it should be moved the 180 degrees. There we go. So if we go now to the indication, the actual position, read actual position, this is the position, okay, but it's 180 degrees. Okay, so that is the idea. So if we go back over here, okay, we have explained this part. Just change the view. So this is show reference nor reversal. I believe, I don't remember if I don't show you before, but the offset, there is something in the offset that, okay, for this one, for the position setting, it doesn't work, or it shouldn't work, because once you select the home by position, just assign that position as a new home. And I don't remember if I already showed you that, but let me just check that for you. So if we go back here, just to show you the first one, here, mode will be 0, which is positioning. Now, if we go over here, this is the position, which, let me just show you the camera, is in there. So now if I execute this, it should be the 0. Okay, and it doesn't pay attention to the offset that I have. Okay, so now let's go back to the explanation for the other homing method. This one. So this one, compared with the other one, is the same idea, but once what it does is to start with the high velocity. Okay, it reached the home position. Okay, as you can see, it waits for the other edge of the position of the offset, okay, for the reference. Then it goes in the opposite way of the movement in low velocity to reach again the home position, okay, and then it goes in forward in the same that it was in low velocity. So probably this one is like a combination of the previous two, and it's good when the machine, when you have the home, the machine is not closed, so it just go in the high velocity, it touch the home sensor, okay, then it go back in low velocity until it sees the sensor again, and then it go back to the home position. So let's try to simulate this part on the software. Okay, so this part is already done, this one is already done, this one is already done, and this one is the one that we need to check now. So let's go to the software. Let's see if I can show you this. Let me just show you the configuration first. So here MW should be 20 because it's the home position. 20, okay. 20 positive. Maybe the rest is the same. I'm going to delete the offset. I don't want any offset here, so we don't get confused on the movement. 0 the offset. Okay, good. And now we can start the movement. Let's see. Going to start the move. So just to recap. So let me just change this. That's okay, it's not in home. So it's going to be in high velocity right here until it touches the home. Once it touches the home, you will start reducing the velocity until I remove the mark of the home position. Then it will go in the opposite way in low speed until it sees the home position again, and it go forward in low velocity until it sees the home position once again. So let's go back here to the software. So I'm going to execute the home. It's going to be in fast position now, in fast velocity. Okay. So now I'm going to touch the home position. Okay. It's in reverse. Okay. Now it will wait until I see the other flank, another trigger, positive, in my case positive, of the home, and it's going forward until I reach the home position once again. Okay, so far so good. Just wait. I just want to leave it on the same position. I'll try to there, almost close. It's manual entry in this case. So we have seen today the different homing methods that we have. As you can see, it's very simple once you know what it does, each of them. So this is it for the homing. So before working with the machine to make an absolute movement or any other movement, it's good to reference everything to the 0, which would be the home. That's why it's important to have the home method enabled, as we see today. So thank you very much for watching this video, and I see you on the next one.